Today we're demonstrating Power-over-Fibre through 100 meters of double clad fibre.
So traditionally hardware such as routers and optical network units, which are like modems, are powered from the mains. And in an all-fibre network they always have to be powered by the mains, and there's no alternative way to do so today. So my goal is to find an alternative by using fibre optic cables as the medium for power transfer.
Power-over-Fibre is useful in cases where you have an all-optical network with no copper cables, and for example, if there's a power cut, the consumer will lose their mains electricity. Now, if the exchange has battery backup and generators, then they can share their resilient power with the customer and power their network hardware purely over optical fibre. The goal of our experiment is to stream a video between two computers. The video server is this laptop here, and it is connected to the optical line terminal, which is abbreviated OLT. The job of the OLT is to convert a data signal into an optical signal. The optical signal is taken to this black box here. In this black box, we have a high power laser. The optics on top of the box combine the data signal with the high power optical feed from the high power laser. It's transmitted through 100 meters of double clad fibre. The Power-over-Fibre power source is derived from these photovoltaic power converters, and it's injected into this cable, which I will later plug into the optical network unit and power it entirely off of the fibre. Currently, it's powered by the mains. So we have the mains supply here. The client receives the video through these cables. The client is located on the other side of the room, and that's where the video being streamed is played. The next step of the demonstration is to unplug the customer equipment from the main supply so that we can replace it with the Power-over-Fibre derived supply. The ONU has powered down. I will now change the cables to the modified cable, which contains the Power-over-Fibre derived supply. Now I will demonstrate Power-over-Fibre. First, I need to use these fans to cool the PPCs for the purposes of this demonstration. This will prevent them from overheating. I will now turn on the high power laser. The laser's power is controlled from this laptop.
I think in this demonstration the double clad fibre we're using is the most interesting part, because we're able to combine the high power optical feed and the signal together without damaging or distorting the signal qualities. The fibre that we're familiar with is standard single mode fibre. It's made of silica and it has one small core. It can carry essentially one ray of light. A double clad fibre, however, has the typical core which can carry one ray of light, but around the fibre we have a very large cladding, and this can carry lots and lots of rays of light. So in the core we carry a small amount of power for our signal, but in the cladding we carry a large amount of power for the optical power feed.
Additionally, we have developed a prototype of a circuit which is able to automatically switch between mains and Power-over-Fibre derived power. This is the mains supply, and this cable here carries power from emulated power converters. When I unplug the main supply, the ONU will reboot automatically. At the customer's home, when the power outage begins, the mains power will turn off. This circuit sees that the mains power has turned off, and it switches on to the Power-over-Fibre derived power.
So the topic of this work is broadly network resilience. If the emergency services can be called to someone who is in need during a power cut or similar emergency using Power-over-Fibre, then yeah, the technology can definitely save lives in some situations. And I enjoy working with all the different types of technology that we have in the lab. I really enjoy the optical part of this work. I hope my work can increase the reliability and resilience of all fibre optic networks.